Welcome to my talk, Getting the Most Out of Symfony 4. My name is Andreas. I've been doing Symfony for virtually forever. And I work for Sensor Labs in Germany. If you don't know who Sensor Labs is, it's the guys behind the framework. We're a French company, and we have offices around the world and in Germany, and that's where I work and a couple of my colleagues. So we do consulting, architecture workshops, trainings, and helping people in general, helping existing teams with the framework. So we have version 4, and actually we have had that since November 2017. And who has worked with version 4? Okay, actually in production? Yeah, sort of. Okay. Okay. Actually, we're going to have a version 4.1 in 2 weeks at the end of May. But actually, this talk is more about 4 because 4 is the major break. Because what we do in releasing Symfony is semantic versioning. For those of you who are not familiar with the term, it means that. In simple terms, it means that we have a three-part version number, and the last one is the patch level, which means bug fixes and security patches. Those come out once a month, or if necessary. We have the minor versions, and minor versions mean we add new features, or we mark existing features as deprecated, which means we mark them for future removal. But you can still use them throughout all the minor versions. And then when a major version comes along, we remove that backwards compatibility layer that has grown through these deprecated features. So that's also the reason why when there is a new major version, we also release at the same time the last minor version of the last major series. That means when 4.0 came out, 3.4 was released at the same time, and 3.4 is basically 4.0 plus the backwards compatibility layer. And so some of the things that I'm talking about today are also related to 3.4 because those were introduced at the same time. Just last week, we had Symfony Live Phantasialand in Germany, which is a large Symfony conference in Germany, and one of the guys giving a talk was Matthias Pegula. He gave a talk about package design, not really related to Symfony, and he had the best illustration ever how this works. So basically, this says everything you need to know about semantic versioning, right? And since we are talking about Symfony 4, that means the major version, that means we are concerned with this in this talk. And there's going to be a lot of new stuff. I think there are 302 feature-related change sets in Symfony 4. In 4.1 there will be 84. And yeah, the point of this talk, of course, is to make this a little easier and see the positive side of things. So what has changed? And when you install Symfony 4, and open it in your IDE, the first thing you're going to notice, of course, are directories. Nothing special here. Might look like this at first sight. So things have changed. The API, the code, has not really changed much. If you followed all the deprecations and removed the deprecations on time, you are pretty much fine with keeping on using the code as itself. But the structure of the project has changed a bit. But it's actually a lot less big thing than you might think at first glance. It's just streamlined to the naming of current frameworks, you could say. So we've moved configuration out of this app folder. We now have a top-level config folder. The web folder was renamed to public, still just the document root. We've moved the var folder before. With Symfony 3, or since Symfony 3, sorry, we've had the var folder, and the vendor folder was always there. So this is nothing really spectacular. You'll get used to the new naming pretty quickly. Inside those directories, a few things have changed. In the biggest change is probably structurally in the config folder, because we have now, to say it simply, we have split up configuration blocks that have formerly been in the config.yaml into their own packages. So every bundle, every component has their own YAML file that is now loaded. Internally, those YAML files will still work exactly the same. There is no difference in syntax or so. So again, this is something you can use to get used to very quickly. There is a reason for that. We get to that later when we are going to talk about Flex. Yeah, another big change is YAML now has 4 letters, which is optional but the new standard. So the public folder has not anymore has several front controllers. We have a single front controller. We are going to look at this also. Again, this is nothing really conceptually different. It's just restructured. If you do a full installation, you will notice that we also have a few features that have moved to the top level as directories. We now have the templates in their own directory, the tests, translations, and so on. Assets, if you install the assets package. Okay. Now I've left out, looking into the source directory, I've left that for last, because in my experience, when I talk to clients teaching Symfony 4, that is, for some reason, this is the biggest wow, because something is missing. Well, we have the kernel now in the source directory, which sort of makes sense. It was always a little awkward having that in the app folder, but so far nothing spectacular. The whole thing, by default at least, the whole thing is mounted as a PSR4 to the app prefix namespace. But the main thing is, oh my god, the bundles are gone. What should I do without a bundle, and why did we remove that? And why is that actually a good thing? Bundles are supposed to be portable. Your application is not portable. Who has worked in projects that looked like this? Okay. Who in ones that look like this? In the best case, I mean, all of these bundles, usually, if you take a closer look, if you analyze them, you will notice that they have interconnected dependencies in all kinds of directions. So there is no portable bundle. And a bundle that is not portable is just a namespace. So there's not really any reason to work in bundles, right? In the best case scenario, you had something like this, where the common dependencies were centralized in one bundle. Usually they were called common, portal, general, main, or whatever. And then at least the dependencies went into one direction, which was sort of an improvement, but still sort of awkward. So we can simply get rid of this. The modular stuff are vendor bundles. Your own application can either be split into several applications if you do the service approach. If you don't do that, it's perfectly fine to simply work in namespaces. That's what namespaces are for. So it's not necessary to have these bundles in your source folder. So it's basically just a simplification, and that simplification has a couple of consequences. First of all, your controllers are named differently. We now get rid of the old controller notation, that three-part colon-separated thing, and now we have fully qualified class names with the action name at the end. We'll get to controllers later. A few things. Some of you might be asking, how do I use dependency injection extensions and compiler passes? I can actually register them in the application kernel now, because we have a build method in the kernel. Although I would claim that this is rather a use case that you don't do that often, because the one single thing that you mostly do with compiler passes are dependency injection tags, handling those, and those make sense in a vendor bundle because they are supposed to enable your bundle to be extended from the outside. So, well, there might be use cases, but it's not that often that you're going to do something like that. Now, the most buzzword thing probably that is new is of course Flex. And actually, I've heard a couple of people that claimed that Symfony was now totally microservice oriented because of Flex, which is just not the case, right? It's just a different kind of installer. And I'm going to explain what is different and why that is actually a good thing. First of all, we have no editions and we have no installer. You remember Symfony editions, right? There was this standard edition, the thing that you always installed, and there is a CMF edition, a REST edition, stuff like that, or could be. So what was the first thing you did when you installed Symfony Standard Edition?
Remove things.
Exactly, you remove things, because it comes with a whole shebang, right? Doctrine and Swift mailer and whatever. So the idea is to go the other way around. And the reason why we couldn't really do that, or why that was not very practical, was because when you install a bundle, you need to do more stuff. You need to add configuration, register routing, I don't know, whatever. So this was always a manual process. And so a plugin-like system where you just install things and then they worked was so far not possible. So what Flex does is, well, Flex is simply a Composer plugin that runs after you run Composer install or Composer update, and it does stuff. What stuff is this? We're going to talk about that. So you start by creating a Composer create project, Symfony skeleton, and then your project name. And if you look at the repo, what Symfony/skeleton is, it's actually nothing more than a single composer.json. And when you run that, that's a little bad to see, but this is the excerpt that you see after the regular composer run has gone through. So Symfony, then the plugin runs, the Symfony Flex runs, and it does some configuration, whatever that means. And it also creates files, and it advises you that these files are yours. So Composer will create files and add them to your project that you must check into your repo, that are now part of your projects and that are editable. So now to explain what really happens when you do that, let's look at what happens when you add Doctrine. You run composer require, so far easy. You can run composer require ORM, which is kind of weird because that's not a package, right? They have to have a slash. So actually, what this is an alias. An alias is just a name for one, or actually a collection of packages, together with something called a recipe that is known by Flex. And Flex resolves this, and what it does is installs Doctrine annotations, cache bundle, Doctrine bundle, Doctrine migration bundles. And again, it does some configuration, and to know what configuration to add and to edit, it uses something that is called a recipe. There are several ways to have recipes. The main recipe repository is GitHub Symfony/recipes. And a recipe, this is the Doctrine bundle recipe. It looks like this. It's just a couple of files. So there's some configuration for the configuration directory, something for the source directory. We're going to look into those. And the one and only important thing is the manifest.json. Because the manifest.json describes what Flex is supposed to do after installation. So it knows that it needs to add the Doctrine bundle to the bundle registry, so it activates this bundle. Basically, that's what was formerly done manually in register bundles in the kernel. And then it can copy from the recipe, the config directory, and the source directory. Those are these that we've just saw. And it can add something to the env file, and this is another chapter that we are going to talk about. So inside the config packages directory, you see this is the Doctrine YAML that gets added, and now you understand why we split up the configuration files, right? Not only are they more organized, they are now addable and removable by Flex easily and less error prone. Symfony Flex writes something that is called a symfony.log file that you, just as the composer log file, you must check into your repository. And that enables Flex to also remove the whole thing. So you can uninstall everything, and composer is going to undo everything, and the ORM will be gone completely. So, if you start out with the skeleton that I've described at the beginning, you are going to go very small steps. You start out with the framework bundle, and you need to add everything by hand. So this is good if you start with an API or something bare bones. If you want a full-blown app, and if you want the old standard edition experience, there is something called the website skeleton, which is more or less what the standard edition was. So you can simply start with this, and it comes with Doctrine, SwiftMailer, and so on. So just what you were used to. Okay. Another significant change in everyday work, or what will be something that you will have to that you will encounter very often, is the handling of environment variables. You might remember that we had this. Nobody used this, but you could use environment variables in Symfony by prefixing them with Symfony __, and then database whatever. And so this is gone. And these were also compiled into the container like every other parameter. Now we can simply use regular environment variables, and the difference is not only the syntax, the difference is also that they will be resolved runtime. So you can actually change an environment variable runtime without clearing the cache, and it will change, which can be useful for all sorts of container service deployments, whatever. If you want to use that one in your Doctrine YAML, for example, so I cut some uninteresting stuff. It might look like this. You have your database URL, and I'm going to shorten that a bit for the time being, for starting the explanation. So you will recognize the percent characters, which are the delimiters for a parameter placeholder. This is easy. And then we have this env delimiter marker, which looks like a function, and then the environment variable name. So if you use this in a placeholder, Symfony will know I have to resolve this environment variable as this parameter. Now, why would I use that? The reason is that the trend when deploying applications goes to configuring your application from the outside through their environment. So an application is supposed to be well, like a package that is immutable, that you can pre-generate, that you can actually even pre-warm the cache in some integration system and then deploy it, and it will configure itself based on the environment. That is something that, of course, if you've worked with Docker, it will come to mind that this is ideally suited to working with containers, but it's actually practical no matter if you're using containers or services or a traditional monolithic web app. It's still practical and useful. The only question that arises if you've never done that is, how do I work on my development machine? Because setting environment variables for all of my projects, that's a lot of a hassle. And so what it actually does is we use the DotEnv component. If you've used Ruby, for example, you might have known this. Python's virtual env is similar in concept. So what it does is, this is an excerpt from the front controller, by the way, from the index.php. So it checks if an environment variable is set, an actual environment variable, and if not, it checks if the .env component is there, and if it's there, it uses .env to load a file that is called .env. This is the reason why it's called .env. And then, well, then it loads everything in this file as actual environment variables that you can then use as real environment variables, because they are. And that is really useful because that .env file is just a sourceable shell file with variables in it. So you can use you can actually use commands in here. You can source that on the shell if you want to run command line tools and have the same environment settings. So it's very standardized and therefore pretty useful. You see in these delimiters that Flex added something here, but you can add your own stuff that will not be touched by Flex. So this basically, in simple terms, this replaces your parameters.yaml. If I recommend that you try this. If for some reason you hate that and you need, for whatever legacy reason, to work the old way with the parameters.yaml, nothing is stopping you, right? So there's no technical reason why you shouldn't create a parameters.yaml. But I actually recommend doing this because that's the new best practices, and it's actually a really useful tool. So what I skipped when I shown this was simplified, I said, because actually the actual statement in the real Doctrine YAML file has this resolve. And this resolve is one of several modifiers that simply means if there are further placeholders inside the value of that environment variable, please resolve them as well. So it's gonna do a resolving of the value. There are several different modifiers. File, it will read the file path that is contained in this environment variable. And who was in the Kubernetes talk yesterday? Yeah, me too. You might remember that Kubernetes has this config map that can export things as files, values as files, and you can use that to mount them, for example, to read them. Or you can use the JSON modifier to convert JSON that is contained in this variable and convert that into an array, associative array or whatever, by running JSON decode on it. you can combine them. So you can load the contents that is in that file and then run it through JSON decode. So you can read multiple variables from this. There are more modifiers. You can cast to integer, modify things or interpret things like a constant, base 64 decode things, stuff like that. And you can add your own actually if you need to. So it's a very powerful tool. But now I need to hurry up a bit. We come to the last and probably another big feature. Who uses a framework that already had autowiring? No names? Okay, good. So Symfony introduced autowiring in 3.3, but it only has come to being full-featured, I think, in 3.4 and 4, because there were a couple of features that have only been added there, and not many people are actually using it from my experience so far. General things about this, it's optional. It is, you can mix this with traditional manual configuration, and you can fine-tune and adapt it to however you like. Manual service configuration. You have a simple service. It's called a runner for some sort of weird game, and it needs a storage and a word list as a dependency, or as two dependencies. So in a traditional manual service configuration, you would do something like this. You would have a service name, you had arguments that were other services. And now the first thing we do, which actually does not have anything to do with autowiring yet, but the first thing we introduced is we use fully qualified class names as the service names, which is very practical. You can now use class constants to get the full name and avoid typos, have auto-completion in IDEs, and get rid of the class argument attribute. Oh, I forgot the class attribute in the last slide. Sorry, this is wrong. There needs to be a class argument there. So you can actually get rid of the class argument here. Okay, so this is the first step. Now imagine, if you think about it, Symfony might be able to do some sort of introspection, and if it has built a container, it just looks at all of the services it has and finds the services that either are this class or are instances of this class or interface. So Symfony should be able to automate this, right? You don't need to configure this manually. Symfony can do that automatically. And this is what autowiring is. Autowiring is simply looking at the complete container configuration and figuring out which service instances can I deduct from the type-ins I have in my code and automate them, so I don't have to do this manually. So I simply mark this as Autowire, true, and it works. Now, when we have this, we can go a step further and use service discovery, because in this case we would have to do everything manually. Still, we would have to mention every service. But now with auto discovery, we can do something like this. Read everything with the app as the app prefix, read everything that is in the source file, source folder, exclude some stuff that cannot be a service or that is already a service. And now everything is suddenly autowired. This is very powerful. There is the question of how do I assign configuration to all of these automatically loaded services? And the answer is, or one of the answers, is this, setting defaults. There is, in the services.yaml, there's a new section, _defaults. And the first and most important thing to remember is this is only valid for this file. So everything you configure here has only an effect on everything that comes below and nowhere else. So you can't accidentally destroy your vendor bundles config or something. This is only valid for this file. And
Okay, check. I take this one. So auto-wiring is by default on, so everything is auto-wired. I can set all the other attributes that you can set to services, like public, false. No worries. We come to the other two parts later. Now, actually, we can. Auto-configuring means, in short, that certain classes, implementing certain interfaces, will receive tags automatically, like twig extensions or even subscribers. So you don't have to tag them manually. Binding resolves a problem that might be apparent, because what I left out when I explained the auto-wiring is that there are some things that cannot be auto-wired, because either they have multiple implementations, so something could be type-hinted as a message interface and there could be several message implementations, or because it's a scalar argument or an array that is not a class and that you cannot directly deduct as a type-hint. In that case, you can bind argument names with a $sign to actual values that will then get auto-wired and get used as auto-wiring. Similar as the defaults, you can do something similar. For instance, off, another block that you can introduce, so that simply means every instance of this interface, no matter what the class, will be configured as lazy and will receive a certain tag. So, a couple slides. I'll be quick. So, the last really important feature where we can finish more or less is this one. Because now that I have everything auto-wired, controllers are auto-wired. That means controllers are services. That means I can inject now every service into a controller. I don't need. This is, for me, one of the most annoying things ever in Symfony was that the controller had the whole container injected, access to the whole container. Very, very bad practice. And now we don't need that anymore, because we can actually, into our actions, we could inject it into the constructor like in every service, but also in the actions we can inject every service by just type hinting it. And that is really, like, for me it's the killer feature because it allows you to write clean controllers, and yeah. So that's the tag that allows you to do that. That action injection is called controller service arguments. It's configured by default. And yeah, there's more stuff to look at. I've left some out because those are more specialized features. These were the biggest ones. Coming soon in 4.1, messaging, we had a whole talk about this, so I left that out on purpose. We will have the fastest PHP router ever in any framework. Avada per server, other practical stuff, and thank you.